Moving from Marie Curie and cooking, we're going to go on to Volker and Thomas's presentation on a new type of fibre that we have available to ourselves. So, leave it to you guys.
Yeah. Good morning. My name is Volker Seidel. I'm from Germany. Our company is called Oekon. I'm together with David and also Albert from Spain in a European group, and our business is comparable to Xylit without dredging, but all the plant systems, the rock rolls and other things are quite similar.
Okay. My name is Thomas. I have a company in northern part of Germany, close to Bremen, and we manufacture since more than 100 years machines and products for subsurface drainage, subsurface irrigation, and products for erosion control. And furthermore, we have a company in Sri Lanka, so we work a lot with coconut fiber. And some years ago, we got access to a new fiber which might replace coconut fiber as a really more efficient fiber.
Okay, the Xylit fiber has we use it for different purposes. The one purpose is to strengthen the self-purifying processes in water bodies, and the other is that we use it for engineer biology. Today I will just have a short presentation of the water purification, and then go more to some projects we did in engineer biology. So it is a fiber that is not yet cold. Normally, if it would be for some more million of years or a lot more pressure, I don't know, then it would be cold. So, but it's still a fiber, and this fiber has a very high porosity and a very, very high surface. And this surface is important for the chemical processes that are important for the Xylit fiber. Here you see another picture. It shows the biofilm because of the absorption capacity. We have a very quick biofilm colonization of the fiber. In general, it's very good, but I think but maybe it's a point later. We see if we have it in a roll, and you see the roll at the nursery, but it's from the shape it's comparable to a coir roll, and we made the experience that it is very quick colonized at the edge, at the rim, and then it's closed a little bit, and in the center you have still the absorption capacity of this fiber, but the water doesn't come in. It's a hydraulic problem. So we are just learning on this. So we had a project in Germany. For the application of this, we tried different shapes. At the moment we are at the rolls. Now Thomas has a possibility to make also mats on it, and we will maybe, for example, yesterday we had floating elements. We can have it as a curtain aside of the floating elements. For example, we will see what hydraulic processes and what absorption processes. Yes. This is a test result in the lab. Perfect. And then we went to more garden ponds, more or less. With that, it is too complicated to have a bigger lake. We would have good chances to earn a lot of money, but we had to guarantee the processes and the results, and we wanted to be serious, and therefore we said we cannot do it. And you see, it is an enormous reduction of phosphorus in this case. And again, no, this is now, I think they are 2 points. The one point is the absorption rate, and the other point is that together with the surface you have a biological process. You have high biological activities. And in a lot of garden ponds you have more or less nothing. You have not even a small area for plants. And then if you put it in a pond, then you have via this surface, via the biological processes, the activities that starts there, until at the end you have zooplankton that eats the algae and everything. I think these two processes are the important things for water purification. So we made in general good experience. I would say when I'm at the phone, about in 80% we have good results in the garden ponds. In 20% we have not good results. And normally you think a garden pond is not too complicated to describe. You know maybe how much leaves you have in, but at the end I don't know. For some reasons I cannot explain why it did not work. And the other thing is what we don't know until now, how long the effects last. This is what I said with biofilm maybe, but when the absorption capacity is over. And also we use it sometimes for floating systems, but we don't know if it's too quick. Of course, we have to know how long the water has to be in connection to the xylit. So this would be maybe another thing to go. This just for the water purification. And now the other thing is I'm absolutely sure that it works, because it is the biodegradation of xylit is more or less nothing. And this is in engineer biology. I think it's a material we've been looking for, because if we take maybe in faggots, we take branches, we take domestic material at the water level, where the water level varies, it is rotten within 2-3 years. That's the experience. Cocoa fiber is a little bit better. It's maybe 5 years. But after 5 years, you must have a protection via plants, or if you have a construction site where you have a permanent protection of the shoreline, then it would be a possibility now to use this xylit. And you see here, that's straw, that's coir, and that's xylit. And you see only in the first 6 months you have biodegradation, but it's only the powder, I think. At the around of the xylit, if you see the xylit, it's the fiber, and you get black hands, like when you are in a chimney. So I think this is only in the beginning, and then you see there in the next year you have only 2% biodegradation, and that's perfect for our engineer biological purposes. And you see here totally other rates with straw. I think you will know. Yeah. So the advantages you see here, somebody standing at a roll. The first is the long lasting. We expect 30 years. So 30 in Germany, 30 years is eternal at a project at the river. The weight is very high, especially if you compare it to coir fibers. So we have about 20 kilograms for a diameter of 25. It's domestic materials. If the discussion comes that coir comes from Sri Lanka or from India. And what also is very important, especially in Germany, they say at the shoreline you must guarantee you say passability for microorganisms or for everything. They must be able to pass parallel to the river maybe or brook, and they have to pass the possibility to pass from the water to the land and from land to the water. Though these are this is here you see we just said faggot, coir rolls, xylit rolls, the durability, the colonization, and the weight. And so everything is for xylit to use it in engineered biology. This is the specification. Normally we have 2 meters. Normally we have 25 centimeters diameter, and it's filled in a synthetic tube. So now some projects we have executed. Here it is a project where maybe you know it also. In former times they used faggots. So the slope is absolutely steep, more or less vertical. So they start from the toe of the slope, what's correct, and then in this case they take boards, and the boards of course are rotten after 5 or 10 years, and therefore they took now the xylit rolls, 3, 4, one above the other, and now they have a system that will not rot anymore, more or less. But the effect for water purification, this is in a rural area where a lot of farmlands was around. It was not possible to see that there was a better water quality. Here we on top of it we put a mat, a pre-planted mat. So I think I will show it at other construction sites. This would be the best solution. So this also, maybe you know it, it's in the north of Germany. Very often they have piles, and in the middle of the piles they have faggots normally. And these faggots are normally rotten after some years. And here we did, we kept the piles, and we just put in between the xylit rolls, and these xylit rolls we have planted then. And then you see after 1 year the result. If we wouldn't have planted spontaneous, maybe 1 year more, but they wanted to have it quite early. So, to other projects, here we took 2 rolls, one pre-planted, one without plants, and here also you have to believe we put the rolls under it and then again a mat on it. Because we say the problem is, if we pre-plant, and I have a picture on the right side, if we pre-plant, we have normally in our basins to put in fertilizer for the development of the plants. But the fertilizer will be absorbed by the xylit, and we will reduce the effect we will have. So normally I say plant it outside, and or we do it in our basin, but we don't put any fertilizer in it, and we accept that the development of the plants is not so good. So we say to the client, yes, it's well rooted now, please take it and install it. So that's another construction site here. Here you see it's a bigger pond with a bad water quality, and we had we wanted to have some structures, literal structures, but here it is about 70 centimeters deep, and if you establish a littoral zone with maybe 10-20 centimeters depth of water, you have to put in some gravel, and you have a limitation, and this limitation we made out of xylit rolls. You see it here, it's not 2 layers, it were 3 layers, and in the middle we had a rock roll, because we haven't been so sure when we put the gravel and the sand behind that it works, but it worked. And you see it here, and then we filled in the gravel and the sand, and we put some mats on it. And this picture I took last week, so it's a very good development. So that's all what I wanted to say. We have not so many projects until now. We will start to increase with this material, because I really think all arguments are for for Xylit in Germany, the tendency is I think from coir rolls to rock rolls to have a bit more or less permanent. But I think now the Xylit rolls we have a middle material from the rot resistance, and of course they have some additional positive effects. Here we had positive effects in the pond, but we had also floating elements. We had other Xylit rolls bound together, so it is not only this one zone we have established.
Probably let me add some more things. The source of the Xylit are trees converted into more or less coal after a period of more than 10, 12, 30 million years. So you also can name it as kind of a bio-charcoal fiber. And we are working on different products. We also have done some really good tests for drainage filters, which are used for subsurface drainage. And especially if we get anaerobe conditions, so if we lay the drain pipe under the water level, we really see a high level of denitrification. And there I think also here we can probably work in a lot of really good and nice projects together with Oekon. We're also in close contact with Silex and kind of exclusive distributor for these products here for UK. We have a lot of other R&D projects where we use the fiber in future, and I see quite a great potential for this.
And I have a brochure in German, but I think quite soon we will have it in English. It's there.
Excellent.